So now that we have our terrain, we can set up the particle simulation that will be sort of the main driver of the whole effect. So we will just have a bunch of points, or not really a bunch of points, but a few points that are spawning right in the center of our terrain, and they are gonna fly outwards in a radial manner. And let's see how we can create this. I will move over here to the side from this. So this network here is our terrain, and over to the side, I'll just drop down an add node, and this will now create a point. So just turn on this point here at 0, 0, 0. So we just create a simple point. And if I just drop this into a pop network, we can see that as I play this animation, we start generating points, and actually let's go inside this PubNet. Let's go to our source, and we don't need to see the guide, so I will turn this off. And for emission type, we have to set this to all points. Okay, and if I go up, as I press play, we can see that we are spawning points. So we are spawning 1 point per frame. Alright, so that's good enough. Let's give these points of velocity. So currently there's only 1 point, and I will create a velocity attribute. So let's drop down here an attribute wrangle, and I will rename this to set v, so set velocity, and I will simply create a velocity. So I will type add v equals set, and in parentheses I will type 0, 0 and 1. So this will now give me a 1 unit length vector that points right in the z direction. So if I were to, let's go to my point over here, we can see that we can now visualize the velocity if I turn this vector trail display on, and here is our velocity. And if I were to play the animation now, all our points are moving in the direction that we specified here in this wrangle. So I want to create 5 points that start from the center and expand outwards, and we can simply do this. If I were to drop this attribute wrangle into a copy and transform, let's actually preview this copy node, and let's preview our points with the trail on. We can see that as I increase this, so we need 5 points here, and as I rotate this, we rotate our vector velocity as well. So we can set up this rotate value procedurally, and I can right click this total number over here, copy parameter, and I will say that our Y rotation is going to be 360 divided by, and I will paste my relative references to this total number here, and now this will update to a value of 72. So now our 5 points complete a full circle. If I were to preview my PubNet now, we can see that we have points spawning in all of our directions. One thing that we can do here is, let's maybe not have our points be evenly split like this, and we want to add a little bit of randomness just so it has a more natural feel to it. After our copy and transform, we'll drop down an attribute VOP, and I will rename this to rand v, so randomize v, and I just want to offset these vectors a little bit. So we can go inside here, and from this ptnum we can generate a random number, or rather a random vector. So if I were to preview this in my v now, we can see that we have a random vector that goes in any direction. The problem here is that we are generating a vector that has only positive values, and a vector can have negative values as well. So we can drop down here a fit after our random, and I want to remap this from 0 to 1 to -1 and 1 on all dimensions. And so I want to combine our original velocity vector with this new random vector. So I will drag my v from over here, and I will just add these two vectors together like so, and plug this here. Okay, and I will also normalize this vector, so the result of these two vectors. So we are working with 1 unit length vectors. And I also want to scale this random vector over here, and this will influence how much of randomness we want our original velocities to have. So I will just drop down here a multiply after the fit. I will promote the second input, and I will set this label to be amp, so for amplitude. Okay, so if I go up, now we can control exactly how much randomness we want in our vectors. I also want these vectors to not have any value on the y direction. So I will go back here, and after the normalize, I want to multiply this result, and I will promote my second input to a constant and set this to be a 3 float constant. And if I were to multiply this by a vector of 1, 1, and 1, we can see that we have our original result. So if I turn this on and off, nothing changes. But if I scale this on the y-axis to 0, we can see that now these vectors are flat on the surface, sort of. Let's also add a custom channel for our seed, so we can control the look even further. And before we generate this random, I will drop down an add node, and I will promote the second input here, and I will rename this to seed. Alright, so if I go up, now we have all the controls that we need, and we can control the seed, so we can change the randomness of the vectors, and we can change how much our randomness influences our original vectors. Okay, so if I were to preview the result now, we can see that it's sort of the same motion, but it just adds a little bit of more of a natural feel. We could assume that in reality maybe lightning strikes won't hit the ground in an exactly evenly spread way. So this is basically just a ground rule of Houdini, is that whenever you can add some randomness to the sources or to any parts of the effect, you should probably do that. Okay, and maybe let's just increase the amplitude a little bit. And I think this will be fine. Now currently the problem is that this is a continuous emission, as you can see, so we only want to generate one particle for each direction. So what's currently happening is that we have 5 points as our source. So if we look here, we can see that we have 5 points, and when these get sourced in our simulation, these are being sourced at their current frame, and then they are being solved, so they move out using the velocity attribute. But each frame we are sourcing in another 5 points, so this is happening each substep. We only want to import our points into the simulation on just one frame. So to only source these points on one frame, we can simply have them only exist for one frame, and we can drop down an attribute wrangle from over here. So after we randomize the V, and I will rename this to set start frame. So here I will create a variable that's called start frame. So I will just simply say float start frame. And let's say that maybe I want the simulation to start at frame number 5, so I will just have the points exist only on frame number 5. So I will set this to equal to 5, and then I can say that if our current frame, so at frame, is not equal to our start frame, I will remove the point. So I will say remove point 0, comma at ptnum. So this will remove all the points. Okay. So what this is saying basically is we determine a start frame, which is currently 5. So when we play our animation, we will check each frame if the current frame is going to be our start frame, and if it's not, we will remove the point. So at frame number 1, this will not be equal to 5, which is our start frame, and so we remove all the points, and then we move forward to 2. So again, it's not going to meet our condition up until to 5, and then at 5 we can see that we have 5 points, and then from 6 and onwards we will just keep running this remove point operation here. So as a result, we will only have the points exist at frame 5, and now when we preview the PopNet, we can see that we are only sourcing one substep, and we only get our 5 points that are being solved by the dot network. And now we can go back and we can add some variation to our start frame. So instead of setting our start frame to 5, we can randomize this value for each of the points. So I will say rand, and in parentheses at ptnum, and I want to fit this value from 0 to 1, so fit 0, 1. I will fit this, let's maybe turn this into channel, so I will say ch, and this will be min frame, and to ch in parentheses max frame. Okay, and I will create these channels. So maybe I want the points to start emitting from maybe frame 5 to maybe frame 14. The problem here is that this will return a float value, so we need to turn these into integers. And we can simply place all of this inside a rint function. So if I type in rint, and I will open parentheses and go to the end and close parentheses, so now this rint is round to integer. So whatever number this will generate, so let's say that maybe this random will give me a value of 4.2. When we place this inside a int, now the value becomes 4, so it becomes an integer, and when we work with frames we need integer values. Alright, so now let's maybe go to our attribute wrangle and preview this. So we can see that as I play this animation, so let's maybe just go forward frame by frame, so I will use my arrow keys for this. And we can see that at frame 5 we have 2 points that are spawning, then no points at frame 6, 1 at 7, 0, 1, and 1 more at frame 12, and this should be our 5 points. So now each of these points will have a different starting frame. So when we go to our simulation, this will now add a little bit of variation to the time at which the particles spawn. So they are offset a little bit.